Meet Alice, an eco-conscious citizen who commutes daily using her electric car. However, she has to constantly toggle between multiple apps on her phone to find and book chargers during an emergency. Can this challenge with the EV charging ecosystem be solved another way? Let us imagine a world where the city has built an open network for energy, powered by Beckn protocol, interconnecting multiple energy service providers and simplifying energy transactions. Alice uses a UEI app of her choice to discover EV charging stations near her. All the charge point operators on the network are able to respond with available chargers. She is able to choose a charging station, assess its availability, and even reserve a slot to charge her car, all over the open network. When Alice begins the search, the request is sent to the network, which then broadcasts the search to the provider platforms. Alice receives a catalog of EV chargers from the provider platforms. Alice selects a charger, which provides a green charging option, and requests a quote. Pulse Energy, which manages this charger, sends the quote for a charging session. Alice accepts the quote, initializing the order, and Pulse Energy sends the final order terms along with the link to pay digitally. Alice makes the payment and confirms the order. Pulse Energy wishes to dispense green energy through its chargers sourced from the city's energy grid. Can this be solved using an open network for energy? Based on the EV charging orders that it has received, Pulse Energy creates demand notes for the amount of energy consumed. Cheru, a virtual energy aggregator, is also on UEI. It attempts to discover and accumulate green energy demand in order to release the surplus stored energy to the grid. Cheru searches for green energy demand on the network and receives a catalog of demand notes from the providers on the network. Cheru selects the demand note created by Pulse Energy and receives the quote. It confirms the purchase by completing the payment to Pulse Energy. At the same time, Turno, a battery aggregator, is refurbishing idle used batteries and generating a second life as energy storage. These batteries are charged by rooftop solar panels. Now, Cheru tries to discover and aggregate surplus energy stores to release to the grid. Cheru searches for battery banks with green energy on the network. It receives the catalog of green energy stored in batteries from providers on the network. Cheru selects the Turno battery and receives a quote. It confirms the purchase of energy from Turno's battery. The battery's charged using solar panels, and the EV charging stations are connected to the grid. As the grid supplies energy to the charging stations, it replenishes the energy from the battery. Prior to using UEI, Alice would find Pulse Energy's charging station through its own app and pay ₹15 per unit of energy to charge her car. But on UEI, she discovers that a charger managed by Pulse Energy is offering green energy at ₹13 per unit. She pays Pulse Energy and completes her charging session. Sheru pays ₹2 per unit to Pulse Energy for a demand note, based on the EV charging order completed by Alice. This is the benefit that gets passed on to Alice. Sheru purchases the energy from Turno's battery bank at ₹1 per unit. Sheru has now spent a total of ₹3 per kilowatt to secure a demand note and surplus green energy. Sheru releases the green energy to the city's energy grid and receives ₹4 per unit.